Okay, good morning to everyone. I will try to explain in a brief way the Open CAPIF component. I am Jorge Moratinos from Telefónica Innovación Digital and colleague of Arturo. I will try to explain the Open CAPIF component, how we create it, and also who is maintaining it, and which is the relevance for 6G-PATH. Okay. Okay, let's move. Okay, what is Open CAPIF? Open CAPIF is developed as an open source code from the Common API framework defined by 3GPP. This component allows the secure and consistent exposure of the APIs. All the development is based on technical specification from 3GPP, as you can see in the PowerPoint. The release 18 and the documents are the technical specification 23.222, 29.222, and 33.122. This CAPIF provides a framework to manage the network and service APIs of a PLMN and to be used by the third party. Telefonica developed the first release on the B5G project, and after that, the ETSI created the software development group to lead the development of the next evolution of the Open CAPIF. Currently, the version in release is the 2.0.0. It was released on this January, and I am the TSC chair of the development. Okay, the Open CAPIF is also being used widely by Sandbox 6G, Imagine, Fidal, 6G-PATH, and SafeCG. And the purpose is to secure the expose of APIs, ensuring the robust and reliable access for different use cases and applications. Okay, the main concepts to keep in mind is the 3GPP specification defines three different entities. One is the API providers, those are the entities that expose the APIs and publish the APIs. The next one is the API invokers, which are the entities that consume the APIs. And the third one is the CAPIF core function, which is the CAPIF itself, okay, the main component. Additionally, the 3GPP defines in the technical specification that the CAPIF core function needs some service or some system to register the different clients and manage them. And that service is not defined, but we propose one service and is present on the Open CAPIF also. Okay. On the other hand, to create this service, we use different components like Python, MongoDB, and Docker to create the images, to create the separate services for each API defined for CAPIF core function and the register service. Also, we create Helm charts to simplify the way to deploy on Kubernetes. And this is the path we follow for the first implementation. We take the 3GPP release 18 APIs. We use an Open API generator tool, which translates the definition on Swagger to services developed on Python. After that, we are including the logic. Okay, this tool only provides the skeleton of the service with the endpoints and the data types. And for the implementation, we also add Nginx and the database and certificate authority. Sorry. Okay, you can see at the right picture the different components. We use the Nginx to expose the CAPI core function and implement the mutual TLS authentication. For the certificate authority, we use Vault because we need to expedite certificates. This is a main functionality, required functionality to implement the CAPI core function. For the database, we use MongoDB. We have two different MongoDBs, one for register service to control the users, and another one to store all the information of the APIs providers and the invokers. To allow the communication between different microservices, we use Redis. The main functionality is Redis is also used, to manage the CAPIF events generation and notification. You can see at the right, all the services are connected through Redis. Okay, the CAPI core function is divided in different services, as I said. Each one is created by by API defined in CAPIF 6G-PATH technical specification. Okay. On the other hand, the CAPI core function can be deployed in Kubernetes because this way to create the services in Docker images and the deployment in services is the next step is to deploy in Kubernetes. Is something easy. And we provide the helms to do that. And also all the development is tested. Currently, we use Robot Framework and we have more than 130 test cases to ensure all the functionality is working as we expect. Okay. About the security, which is the important thing for 6G-PATH, the CAPI core function communication with API invokers and providers is based in TLS mutual authentication. And the implementation includes the certificate authority, as I said, to expedite certificates to interact with the CAPI core function by invokers and providers. And the API consumption between API invokers and API providers supports the three different security mechanisms: PSK, certificates, and OAuth. This is the main flow defined by the specifications. I will move to the demonstration because it's easier to understand this flow seeing the demonstration, okay? If you don't hear the video, please tell me.
The first step is for a user to ask an administrator to use CAPIF. Then the administrator will have to create a user. But first, the admin will have to log in with his credentials to obtain a token that gives him authorization to perform operations that the user cannot do. On the login endpoint, we can use basic out and the admin credentials to get two tokens. The access token that allows the admin to perform operations on the register, and the refresh token, which allows the access token to be updated without having to log in again. Now, with the token, we can create a new user. The important fields, in this case the username and password, can be given by the user or created by the admins, and will be the credentials that the user will use to request the CAPIF access token. Our next step will be to register a provider and publish an API in CAPIF. Using the credentials obtained previously, custom user and user pass, making the request to the register service. We obtain all the data that we need to make the following request. These data are the access token necessary to register a provider or an invoker in CAPIF, the CR root certificate, and the URLs where to make the request. Now we need to register the provider. To register a provider, we need to make a request to CCF API onboarding URL, and we need to use the access token that we obtain. In the request body, we have a list with the provider's functions that are the AEF that expose the API, the APF that is in charge of the publication of APIs, and the AMF that manage all the functions of the provider. We move to the response. We can see the location of the created resource, the ID of the new provider. For each of these functions, we will obtain an identifier and a certificate. From here, we will need to use a specific certificate for each request. As our next step is to publish an API, we will use the APF certificate and the publication URL. This is the publication URL, and in the body of the request, we will introduce a description of the API. This description contains the name of the API, in this case, Demo API 1 Open CAPIF, the ID of the AEF that expose this API, and its resources. And finally, we also have the interface descriptions that contains the IP, the port, and the security methods supported by the API. In response, we find in the header the location of the resource and the identifier of the API. So with this, we will only have to start our API. We have our API already started. To register an invoker, we start by doing the same as with the provider. And as you can see, we use the credentials of the user that we create before. We make the request to the register service, and we obtain the same as the provider. Once we have everything, we can register the invoker using the CCF onboarding URL and the access token. So, okay, using this case, the CAPIF URL with the CCF onboarding URL and the access token, we can register the invoker. And in the response, we obtain the location of the resource of the created resource and identifier of the invoker and the certificate also of the invoker. From now, we will use the certificate for all requests. So now, as an invoker, we are going to check which API are published in CAPIF using the Discover service. If we put Discover service, debug mode, in this case, we have only 5 published APIs. As we can see, the last one, the Demo API 1 Open CAPIF, is that the one that we published before. And this service also returns all the information about the APIs. If you remember, this API has three resources: create VM, check VM, remove VM, and we also can see the interface description. Now what we want is to use the demo API 1. We need to create a security context that allow us to obtain a token which is necessary to make the request. So the first request will be to create a security context for the API demo API 1 CAPIF here, okay? And the request, in this case, we use the security URL. The request, we have a list with the preferred security method. In this case, is only WAP, and the information about the API, the AEF ID of the that expose the API and its ID. As response, CAPIF creates the security context and returns in headers the location of the resource. And in the body, we can see the selected security method to use. In this case, we only have WAUs. The selected security method is WAUs. And once the security context has been created, all we have to do is ask for the token to make the request. Okay. So the security token for the API 1. We request the token using our credentials, the invoker ID, and setting the scope of the token with the following pattern. The 6G-PATH hashtag AEF ID, or that expose the API, followed by the name of the API. And in response, we obtain the security token, the token type, in this case, bearer, and the expires time. In this case, we have 10 minutes to use the token. Now we can make the request to the service that we have published. What this service will do is create a virtual machine in an environment that we have. So if we call service, in this case the service demo AP1 in CAPIF, if you remember, we have three endpoints. In this case, we use the post method and the endpoint create VM. This endpoint also needs a body. So we are going to put here the root of the body. And if I make the request, we see that we use the token received, and we have created a machine called demo1 VM with the ID 1091. And with this, the demo will be end. We have been able to create a user as a CAPIF administrator, register a provider with which to publish an API, and register an invoker with which we have discovered all the APIs published in CAPIF and created a security context to use an API to consume said API.
Okay. The demo is over. Let's see. Oh, sorry. I am trying to move here. Okay, the video is a little bit shortened, okay, because it's a little longer than you see. Is upload to the YouTube, and in this link you can see the complete video if you want more information. On the other hand, if you need something to clarify, please do not hesitate to contact me or Arturo, and we can talk about the Open CAPIF and the flows and all you need. Okay, just to finish the presentation, I want to speak about the relevance for 6G-PATH. Okay. The Open CAPIF provides a secure, the key points for 6G-PATH are the Open CAPIF provides a secure consumption of network APIs by third parties. As you can see here, is currently a component of security as a service in the UMA testbed. And the key aspect of security related with the CAPIF are the authentication, ensuring that only the valid user or systems can access to the Open CAPIF resources. The authorization it determines the API access based on the predefined roles and policies, ensuring each user or system only has access to the authorized resources. Another key important key aspect is the encryption using the mutual TLS communication. And the monitoring and auditing are provided by Open CAPIF as a functionality to monitor the API usage and auditing all the messages shared between the invoker and provider. About the compliance and regulatory adherence, the Open CAPIF facilitates the implementation of compliance policies with security standards and other regulatory requirements specific to the industry, ensuring the proper access and use of the APIs. And about the third-party security, with the authentication and authorization, the third parties through the credential management process, ensure they are meeting the security requirements before granting the access to the APIs. This minimizes the potential risk. Okay, and that's all.